For more information, please visit our website at DarkCybernetics.com. This is DarkCybernetics Space Shooter Games in SDL2. Follow along with our free course documentation. In this video, we will discuss using the Simple Directmedia Layer for taking in user input and then regulating the frames per second. Regulating the frames per second in the Simple Directmedia Layer generally involves some type of operation which takes in the number of frames, how much time that has passed, and using functions such as SDL get ticks and SDL delay, which return time in milliseconds. To regulate the input, we would need to poll those events using some type of SDL event structure. Our target frames per second for a two-dimensional game for a screen that is 600 by or 800 by 600 would be somewhere around 60 frames per second. And we're talking about the number of entire frames of animation which take place inside of a second. So using SDL delay and SDL get ticks together in one type of operation. Suppose we had a screen and we were making a tennis game and we placed players on the screen. If we never refreshed the screen, the player would be like a crayon cursor, a crayon, and it would draw over the screen and it would just be the color of the player. So what we want to do is try to play over and determine where the character should be on the screen and what type of operations take place with the player, at which make the game seem smooth and have a nice even orientation. So in SDL, the origin 0 is up in the top left hand corner. So our X goes this way and our Y goes down that way, which is different in OpenGL. Well, so we say frames per second. We want to make a function that regulates the total number of frames per second. We use SDL get ticks again, right? We're going to use SDL delay, and we want to have some variables or about how much time has passed, the whole total number of frames, and our target time, right? So if our target time was 60 frames per second, we would have to do that inside a program. Well, one problem comes in if we're new to programming, and I hear that programmers type 100,000 lines of code, and what do we need to do? Well, inside of our game project, we might have a GUI relationship components, right? So we have a part in the game loop that determines when the game is active, when we end the game, what game options take place, when does the game start, does the game slide into some type of get demo or shadow play. From our game settings, does it fall into a save state, and other features which may need to go back into a loop which determine what the settings are default. So from the game menu, we may need to go back into the game settings to change the game settings to match different devices. One thing we can do to improve the quality of our game sales is releasing teaser trailers, and we're saying that a trailer is just advertisement for the game. And a lot of websites have social media platforms they use to push game sales. Uh, 100,000 lines of code seems like a lot of code, but in SDL programming, you can get a platformer up and running in 30 lines of code. Well, a lot of the information, 100,000 lines of code, may just be audio files, path names, map data, right? Music, multi-platform support. So we have multi-platform support. It supports for Windows, Macintosh, Linux, mobile devices. And a modern game may have dialogue, especially for a three-dimensional game. There may be voiceovers and things. For a simple game engine, but even with all these attributes, may only be around 1,000 lines of code. We think about we had 10 classes. We divide that, there were 50 operations being performed over a header file and a CPP file, right? And then we have our basic game in less than 100,000 lines of code, right? Easy, simple for SDL. So we want to make sure that we know some other things about C++. C++ and C relatively different, and a lot of these languages and APIs such as SDL and OpenGL have different varied ways of working. We do mathematics using operators, and if we overnest a program, we may increase the complexity, so that increases the time it takes for an operation to perform or for it to check in a loop, right? And if we have logical errors, we create freezes and crashes, right? If we bound up the memory too much, the game will crash. And if you're not familiar with linked lists, we need to look those up. There are certain keyword pointers that, if you point to nowhere, we use no. So for those of you who aren't familiar with object-oriented programming, you may need to do some work, and we may go over some concepts in this video series. So in C++ and a lot of programming languages, everything is left assigned. So if we want to calculate the price of a car, we may need to add the total price of the purchase fee to the sales tax fee. C++ is case sensitive, right? And most words are lowercase. Most loops inside of many programming languages have a for and a while loop, and what we call the programming is a statement, right? The part of the argument is a statement, and then there are incrementals and decrementers to increase the loop state, right? Making objects is easy inside C++ and SDL. We just need to name the object. So if you have SDL window, we call our window, right? And if we want to have a love and hate relationship by using information on one class to another, we need to use the scope operators. We just dot, right? The branching in a lot of languages is if else, case break. Some languages have a try-catch block, right? And one example of these things being broken or wrong is we have an if loop to check for loops, errors. Right? Suppose we didn't have the textures, right? No textures, we need to return some kind of function that tells us that the program did not execute a certain piece of code. Keywords, we cannot use keywords like integers and long and short and things like this are bad variable names because they're keywords. So what thing would be wrong is to say if we had an int that was 5. We can't do that. We have to say there's an integer, there's a number that is equal to 5. That's okay. So other ways of doing this, we can just have an int that is 5, and some ways of playing with these things, right? There's also other different types of data sizes. They're different. They take about different amounts of memory. We can make things constant, or we can define them. We can say that we want the screen height to be something. Oh, this is probably wrong here too, right? We didn't use the equal sign, right? And we have integer arrays, and we can assign each one of the integer arrays to a certain different value. And integers in C++ start at 0, right? And we read from the left to the right. Okay. Boolean values taking true or false. A character might be a single value, and strings and spaces can be read into C++. It's okay. That's all right, right? It's okay. Well, we're talking about the actual code. We mean the source code. All right, and we're talking about the written description. That's the pseudocode. And we're talking about binary operations. We're talking about 1 and 0. Our executables are .exe files, .jar file, right? And we are using a high-level language like Java, Perl, Python, okay, which may also be supported in SDL. For our homework, right? There's homework. Sorry, guys, there's homework. We have to read some stuff. The SDL documentation. If you're not familiar with OpenGL, we need to look over OpenGL documentation, and we also need to name and document what we use. If we do not name and document and date things, we get confused. There's no discussion, and we lose information, right? So what is our player? We're talking about our perspective avatar. Okay, that's the character, right? What are our enemies? Foes that harm the player. So we have to do this and play with this in the code. How do we score? Scoring, that's how we achieve progression inside the game. What is the GUI? It's a graphical user interface. This is what the main menu we see. The health bars, the life, the controls. Sometimes on a mobile game they're on the screen, right? And what are copyright laws? Well, suppose we wanted to go and make our favorite animated series game. We won't enter the name here. There's a lot of copyright infringement things we can say about a game, but these things are illegal, right? So we want to say that we made things ourselves, and we like to be like independent. So we're not using a lot of images in this video about other different types of game types, because make sure you draw your own assets. If you want to make a project, make sure you use your own things and own things. There's a lot of legal issues we get into, and you can receive a cease and desist letter from someone, which is not good for you, not good for your future. Okay. Well, do all games have classes? No, we don't have to have classes for all things. For our first programs, we won't have any classes. We're just going to make sure it works. The goal is to make sure things work first, then we fix it. When do we start using classes? Well, we start using classes when there's enough memory, when we think we can fit this stuff. And that's once you start adding things, we can't fit, a few 100,000 files into 40 megabytes. That's not going to happen today, right? And suppose, what are the benefits using object-oriented programming? Well, some of the benefits of using object-oriented programming is easier for updating features of SDL or the API, and we can break things down to modules, which we can make things easier for debugging or fixing errors, because you may have a lot of them. Well, if we wanted to do 3D programming inside the Simple Directmedia Layer, we would need to look over information. I mean, you can do graphics inside C++ without using OpenGL SDLs, but we have to use a lot of math for that. And since we want things to be easy, we need to look over the documentation, and you need to be aware that these functions depreciate from time to time, and C and SDL are both written in C, and so both of them don't really have the support for classes. I mean, it's been a feature that has been added to the last few years, and it takes some work to get things around, get them working the way you want them to work. And rendering in OpenGL and C++, OpenGL and the Simple Directmedia Layer are a bit different, because in the OpenGL we need to know the rendering context, and there are functions in SDL which help us determine the rendering context. Well, in the original legacy version of OpenGL, we had a fixed function pipeline, and since then we're on version 4.6 in this video. There's been support for a programmable pipeline. There are support for shaders. That's why we do shadows and lighting. And with new hardware, new research in computer graphics, we can change these things, right? For this video series, you may think about using the 3.0, because we're worried about graphical support. So if our computer does not support these things, the game will crash, and that's just reality. Suppose we want to use ray tracing, which is new in the RTX series of cards. If our game does not support this, there's ways in OpenGL and other libraries to go between these areas. Suppose our computer didn't have all the right features, we would need to tell the system that we don't have these things, we want to work anyway, right? We don't have all the qualifications, but we still want the job. Okay, we can do that now. And we will not be using DirectX in this video series, because it changes too often for beginners, right? Well, we'll be using Glue, and Glue is the OpenGL extension Wrangler library, and is available here at this website. And installation is similar to that of the Simple Directmedia Layer. If you want to use the Visual Studio compiler for this, we go to Project Properties, we go to Linker Input, and then we would add these arguments down here, this glue 32d.lib and OpenGL 32lib and SDL2, glue 32lib, OpenGL 32lib, SDL2 main lib, and SDL2lib. If you're using the CodeBlocks compiler, it's just a dash in front of it. Right, and you put an L in front of it, and then because we're using the library, you'll get it. It works fine, right? So what about the extension Wrangler? Well, it's also a cross-platform library, and we can use it to access some of the other features of OpenGL. We don't have to worry about glut and just because you can also just use certain features of OpenGL. This one has enough of what we need to do our projects. So if we want to install other libraries like SDL Mixer, they have the same process. You put dash L on image and dash mixer. If you want to add audio and sound to our projects, it's the same process, right? We need to know the lib and include folders, and we don't want to make a habit of using. Suppose our API had other forms of input. We don't want to mix up inputs. We want to use everything. If the SDL has input, just use the SDL inputs. If, there's other graphical tools that have their own forms of input. If you're using DirectX, for example, or others that have their own type of input, we want to keep input one way, right? Well, there are 3 common ways of doing input in a lot of PC games, right? There's the keyboard. We're talking about the US QWERTY keyboard. The mouse. We're talking about a 2-button mouse with a center scroll button. And there's the joystick, the 8-button gamepad, right? Gamepads also have analog sticks. That's important too now for a lot of 3-dimensional games. Not so important for 2-dimensional games because people still like the button press feature. And there are analog sticks on mobile devices, and SDL has its own form of input. There are things not to do with user input. We don't want input to be too complex. A lot of ways to program input is just to have a set of Boolean states, and if a set of buttons are pressed, they go yes or no, and then we just have a function that tells us which buttons are pressed, and we have logic based on that. Because once we increase the complexity, it slows our game down. It slows down our operations, and it slows down the way things are performed in the game. And so there's 2 concepts we think about: constant time, we're talking about at math, and there's linear time, and there's other times higher than that. We go into quadratic time. A constant time operation would be finding a person named John Doe, right? A random person's mom's birthday year, right? We know where it is and when it is. We know there's we can check that out, right? And that's easy. We can do a little bit of math and find that out. That's a constant time operation. A linear time operation would be finding the day of the week by searching, right? We have to search something. Go through the entire list of things. We got to go through a bunch of eggs Easter to looking for. We look at a bunch of there's a bunch of baskets. We want to look through each basket for an egg. That's linear time operation. If suppose the baskets were closed, that's linear time. There's other concepts like linear probing, which we'll get into later. All right, and there's other quadratic time. Quadratic time operation would be like trying to find your keys. They look over the same operation, the same area several times, right? Okay. So taking in user input, we're gonna have a function that checks for a single input if it's pressed, right? We can check for a combination of key presses. We can have a queue of button combinations. We can check and see if the button's released. And we're going to check for legal inputs. Certain games, it's possible to press all the buttons on a game controller, but for a keyboard it might be impossible, right? There are games like Kingdom Hearts. If you press all the buttons, you can restart the controller for the original PlayStation 2 version. Pressing up and down might be illegal for a game controller, because when would you have to press up and down on a game controller? It's not a fighting game. If it's not a fighting game, you know, it'd be illegal. And it really depends on the input device or what type of features we're trying to implement. For the keyboard and mouse input states, there's states like is the key pressed down? Is the key being pressed? Is there the key being released? And is this a mouse click, right? There are common input keys. The QWE, ASD, TR, ZXC, IJKL are common input buttons. Our 1 through 9 are hotkeys a lot of times for a lot of games. Our controls is really based on if you're left or right-handed, right? Spacebar, enter, escape, and our first 5 function keys are usually what you use for most games, right? The ones beyond that are usually used for system things. I mean, we don't really go those far. We're taking screenshots, and that hardly ever happens, right? So, how are we going to code this up? Well, for a keyboard, we're going to change the way things work, right? We're going to look at the way the character moves. So some games, changing the X and Y value for a fixed region moves the character. And for other games, this is not possible. Games like Zelda, the character moves. If pressing X and Y increments the value of X and Y for a player, and that moves around the screen. For a character, for other characters, for other types of games, the screen just scrolls. Moving, pressing up and down X and Y just moves the character back and forth. This is something that's not usually performed in simulations. Simulations, you may not have any control over the screen, right? If you're playing a real-time strategy game, the characters move, and you click on the map, and they don't really affect the screen scrolling, right? The mouse does that. It depends on what type of game we are using. So if we have for a mouse, and the mouse controls is just completely different. There's one problem people have is if you're using Macintosh, is this a standard keyboard? How can I play this three-dimensional game or two-dimensional game with one button once? Can I change the keys, right? Is my mouse moving too fast? Is it too slow? Are you left or right-handed? And these are problems that come up, right? Do I really need to have a mouse cursor? No, that should be seen on the screen, right? These things come up, right? Well, joystick controllers. Well, if I only have a keyboard, right? Do we need to toggle going into the keyboard or turning the keyboard off? Should it be on? Should it be off, right? And the controls for a phone are similar to a mouse and a keyboard, and joystick is simple to control. So if we get something working in the keyboard, we just need to convert it over. Just need to know the SDL functions, and we have to make sure we pick the right SDL functions to implement these things. Well, suppose we had a main loop and we initialized main and we did everything and we quit SDL. We need to talk about adding SDL headers and turn on subsystems, and what is our game loop. Inside our game loop we have functions. And what are those functions? We have functions that tell what type of game actions take place. We have a game loop, and the game loop generally is a Boolean value. So it tells us, did we die? It could be anything, right? Inside the game loop, did we check the user input? Did we draw images to the screen, regulate the frames per second? For each position, do we update? At the end of this, we usually would free up the memory, right? We would call some function, some deconstructor, to terminate these things, right? After the sound. These things, they happen in different ways. If we want to just alter our main loop, all we'd have to do is say have a header. Suppose it was space shooter header, and we just say we have a space shooter class, and we would change it. We just make an object of it and call it from the other side. Our class would look something like this. Suppose we had a car class. There are parts of the car class that are public. A lot of times public is a keyword, so public may be lowercase, right? Just for this example, a public function would be something like controlling all the movement for all the characters. Everyone could access movement, right? But something private would be like knowing the X and Y for a vehicle, right? You know, a car is X and Y, a truck's X and Y, right? How we make classes is similar. The work goes on one file, the declarations go into the headers. Okay. In the initialization of SDL, there are a lot of SDL functions. There's SDL init timer that tells us the timer subsystems. There's one for audio. There's joystick, controller. These things are different. You have to look and we have to read the documentation for these two things, right? And we just use SDL to knit everything. SDL to knit everything because we just want to use everything. We know everything. Because, you know, remembering or, you know, changing takes a lot of time, right? So, to recap, we use SDL mixer for sound. We use images for image formats, and we use TTF for text font. If we use SDL quit, we turn off SDL subsystems. It's a function that just returns nothing. It can be left empty. If we don't put void in there, void is just a keyword. Can't use that either, right? We can also check for event types. We use SDL event, and then for the SDL renderer, we put things to the screen. We put things to the screen by using SDL present renderer, and we put the renderer inside of it, the object of the renderer. Some functions require require references, and we use the ampersand sign for that. And we check out the SDL event page, right? There are different types of events. For Windows, we need to make an event for the window. For keyboard events, and there's even events for the wheel, right? There's different type of functions which need to be looked up online because we can't just, you know, type all these things out, you know, because sometimes there may be a spelling error or there may be different input devices, and they vary. They vary because I've purchased some mice which read like game controllers, so you have to really look at your device. If we use copy render, that's different, and for a window, we need to make a window object. For a surface, we need to we have something to draw to. For textures, is what we use. We can convert the textures, the surface into textures. And if we use SDL rec, we're talking about a rectangular structure, right? For our constructor was where we do the work, and our deconstructor is where we get rid of things. So the SDL destroy and SDL free surface we usually place those inside of the deconstructor. Whatever type, we need to get rid of all the textures, or we need to get rid of all the sounds. We put those in there. And if we are new to C++ programming, new variables that are unassigned need to be set to 0, because they have a lot of times they have junk variables in them, junk values just for memory. And the build and run buttons are different inside of the 3 compilers. If you're using the code blocks compiler, the code blocks compiler is at the top. It's usually always in the same spot, and a lot of times it's just F5 to press to work. Okay, so for screen size, SDL has support for getting the screen size for the different types of screen resolutions, and our refresh rate is usually a lot of times at 60 megahertz. That's really based on our monitor. Okay, and there's also ways to manipulate the image, because since they change so often, there are ways in SDL to get the exact screen width and exact screen height. You can also get the desktop resolution in SDL, right? We're going to keep everything out of main. If we have different classes, just use this slide as an example for updating, relating levels. And a lot of times you need to update and you need to name your project. You need to document the code every time. And if we need help, with a lot of ways to do these things is just to go online and look for help. If you're not online looking for help, we may not finish anything. A single image is a sprite, and a collection of those images is a sprite sheet. In our later videos, we will talk about using animations and sprite sheets. Screen size changed in the early 2000s, and the screen resolution tends to be a bit longer in the x-axis. And so if we draw tiles to the screen, if we do the math, we just divide it by the number of tiles on the screen. We get 20 goes across and 15 goes down. That gives us our height and width. And some games have a smaller tile size. If you look at Diablo 2, to do lighting effects, they have a different size and width screen resolution for drawing sprites. For object movement, for platformers, you generally just go left and right. And we do gravity. We do have a function that determines the jump and speed at the time. For RPGs, we generally just go up, down, left, and right. And for top-down shooters, we need to move in all 8 cardinal directions. Well, after we add the SDL2 header to our project, we convert memory from RAM to the GPU. So we have to use the image, and we just find the type of image and we load it. If it's a PNG, it'll change from save BMP to PNG, and we create a texture from the surface, right? For our start screen, we need to have whatever the name of the game. If we used a mouse, we had a region around it. We need to know, is there supposed to be some type of sound or music? What are the game controls? Should we have default settings? And what type of game features makes our project unique? One problem that usually comes in for the start button, we're going to load the current game settings. For our options tab, we're going to have variables that change in the game features. And our extra screen is also accessible inside of our game. So we need to turn the game off. Do we need to go back to the main menu? These are also important. And one thing we need to check for is to do the buttons work. Why does this screen freeze? And should these things be highlighted? These things come up, right? Attacking inside a game is different than shooting inside of a game. right? So for an attacking object, for a player with movement, shooting and attacking are two different things, right? Attacking is generally a connected object. It's the same thing. We just create a rect in front of it. And shooting is just giving a velocity to the object you just created. And gravity for a two-dimensional game is just we need to know the time and the speed, and we have a variable that regulates the speed. And for more information, please visit our website at DarkCybernetics.com.